Is the universe predictable? Or is randomness built into reality itself? For centuries, physicists believed the universe followed strict, deterministic laws. If you knew the position and motion of every particle, you could predict the future perfectly. But modern physics tells a very different story. At the smallest scales, the universe may not be predictable at all. It may be fundamentally probabilistic, and understanding why has led physicists through some of the strangest discoveries in science. Before the 20th century, physics appeared completely deterministic. Newton's laws described motion with extraordinary precision. If you knew the forces acting on an object, you could calculate exactly how it would move. This idea was pushed to its extreme by the French mathematician Pierre-Simon Laplace. He imagined a hypothetical intelligence, now called Laplace's demon, that knew the position and momentum of every particle in the universe. With that information, the demon could predict the entire future. In this classical picture, nothing is truly random. Randomness only reflects our ignorance. But that view began to break down in the early 1900s, when physicists started studying atoms and subatomic particles. They discovered something strange. At the quantum level, nature behaves very differently. Instead of precise predictions, quantum mechanics gives probabilities. For example, we can predict where an electron is likely to be found, but not exactly where it will appear. The same idea applies to radioactive decay. Take a radioactive atom. We can measure its half-life, the average time it takes for half of a large sample to decay. But any individual atom might decay in a second, or survive for millions of years. There is no internal clock telling it when to decay. The only thing physics can predict is the probability. This suggests something radical. Randomness may not just be a limitation of our knowledge. It may be part of the structure of reality itself. Not everyone accepted this idea. Albert Einstein was one of quantum mechanics' founders, but he was deeply uncomfortable with its probabilistic nature. He believed that the universe must ultimately follow hidden deterministic laws. Einstein famously said, "God does not play dice with the universe." To illustrate what he saw as a problem, Einstein and his colleagues proposed a thought experiment involving quantum entanglement. When two particles become entangled, their properties become linked. Measure one particle, and the other instantly reflects the corresponding result, even if they are separated by vast distances. To Einstein, this seemed impossible. He called it spooky action at a distance. He suspected that hidden variables, unknown factors, might secretly determine the outcomes. In 1964, physicist John Bell developed a way to test Einstein's idea. Bell showed that if hidden variables controlled quantum outcomes, certain statistical limits should appear in experiments. These limits are known as Bell inequalities. Quantum mechanics predicted something different. It predicted that entangled particles would violate those limits. Over the following decades, physicists performed increasingly precise experiments. Pairs of entangled particles were created and measured under carefully controlled conditions. Again and again, the results violated Bell's inequalities. The predictions of quantum mechanics were correct, and many hidden variable explanations were ruled out. Bell's theorem revealed something profound. The universe cannot simultaneously satisfy two classical assumptions: locality and determinism. Locality means that influences cannot travel faster than light. Determinism means that outcomes are predetermined by hidden variables. Quantum experiments suggest that at least one of these ideas must be wrong. In other words, reality may be fundamentally different from the picture classical physics once imagined. So, does this mean the universe is truly random? That question is still debated. Quantum mechanics clearly describes events probabilistically, but physicists continue to explore deeper explanations. Some interpretations suggest randomness is fundamental. Others propose that the universe may follow deeper laws that we do not yet understand. What is clear is that the deterministic clockwork universe imagined in the 19th century no longer describes reality. At the smallest scales, nature behaves in ways that challenge our intuition. The deeper we explore the laws of physics, the stranger the universe appears. From radioactive decay to quantum entanglement and Bell's theorem, modern experiments suggest that probability is woven into the fabric of reality. The universe may not be a perfectly predictable machine. It may be something far more subtle. This is Infinite Narratives. Subscribe for more cosmic mysteries.